Today, I am going to talk about similarity and enlargement, an important topic in geometry that helps us understand how shapes relate to each other when their sizes change, but their forms remain the same. I will begin by explaining the concept and properties of similarity. Two shapes are said to be similar if they have the same shape, but not necessarily the same size. The key properties of similar figures are that corresponding angles are equal, corresponding sides are proportional, and the shapes have the same orientation. Similar figures may be enlarged or reduced versions of each other. Next, I will explain the idea of the linear scale factor and the center of enlargement. The linear scale factor is the ratio of the length of a side in the enlarged image to the corresponding side in the original figure. If the scale factor is greater than 1, the image is an enlargement, while a scale factor between 0 and 1 results in a reduction. The center of enlargement is a fixed point from which all points of the original figure are enlarged or reduced. Every point on the image lies on a straight line drawn from the center through the corresponding point on the original shape. I will now discuss enlargement on a plane surface. In plane geometry, enlargement involves increasing or decreasing the size of a figure while keeping its shape unchanged. Each point of the figure moves away from or towards the center of enlargement according to the scale factor, resulting in a similar image on the same plane. Next, I will explain enlargement on the Cartesian plane. When a figure is enlarged on a Cartesian plane, the coordinates of each point are multiplied by the scale factor if the center of enlargement is the origin. If the center is not at the origin, the coordinates are adjusted relative to the center before applying the scale factor. This method helps us represent enlargement accurately using coordinate geometry. I will now explain the area scale factor. When a shape is enlarged or reduced, its area does not change by the same scale factor as its sides. Instead, the area scale factor is the square of the linear scale factor. For example, if the linear scale factor is 2, the area scale factor becomes 4. I will then explain the volume scale factor, which applies to three-dimensional shapes. The volume scale factor is the cube of the linear scale factor. This means that if the linear scale factor is 3, the volume of the enlarged solid becomes 27 times the original volume. Finally, I will talk about the applications of similarity and enlargement in real life. These concepts are widely used in map reading, architectural drawings, engineering designs, photography, model making, and scale diagrams. They are also applied in medicine, astronomy, and computer graphics to represent objects accurately at different sizes. In conclusion, similarity and enlargement help us understand how shapes and objects change in size while maintaining their form. Mastering these concepts enables us to solve geometric problems accurately and apply mathematics to real-life situations effectively. Thank you for listening.